All right. Here we are in 8.2, and we are applying exponent properties involving quotients. So earlier we had the product of powers property and then the power of powers properties. Some of those things we may be incorporating in today's lesson, but what's going to be new is what is called the quotient of power properties, which states that if you divide um, powers having the same base, you end up subtracting the exponents. So, like in this case, you have 4, which is the same base, and the top is 4 to the 7th power, and then you're dividing by 4 to the 2nd power. By using the quotient power properties, you're saying that it's 4 to the 7 minus 2, which then that equals 4 to the 5th. So if we were to generalize this and say, instead of using numbers, say we had a variable such as a, and it was to the m power divided by a to the n, this would be saying we're going to say a to the m minus n. So that's the general definition for quotient power properties. So looking at example A, this is where we're going to incorporate using the uh, power of powers. And we're going to attach x to the third divided by y to the third. Now keep in mind, they are not the same base. On the numerator, we have a base of x, and in the denominator, we have a base of y. Since they don't have the same base, we leave it as this is the answer. Looking at B, we can, again, we're going to use the power of powers property to square -7, and also we're going to square x. So this leaves me with -x squared divided, -7 squared divided by x squared. And -7 squared ends up being 49, because -7 times -7 equals 49. And this leaves us with x squared. Let me get some more room here. Let me extend the page. Okay. For example C, all right, first off, I'm going to use the power properties. So I'm going to go 1 to the 4th divided by 3 to the 4th. But 1 to the 4th ends up equaling 1 divided by 3 to the 4th. But I'm going to multiply by 3 to the 12th. So then this ends up equaling 3 to the 12th divided by 3 to the 4th. Now we have the same base. We have a base of 3, both in the numerator and in the denominator. And we can use the quotient powers property, and we can say that it's going to be 3, and it's going to be 12 minus 4, which then equals 3 to the 8th power. I don't know what 3 times 3 times 3, 8 times equals, but I'll leave that as an acceptable answer. Okay. So now we not only do we have some examples that have numbers and variables together, and we can incorporate maybe not only using the quotient power properties, we also use the power properties. So again, this parentheses all the way to the third power, which means is that you're going to use the power of power properties with every value in the numerator and into the denominator. So that means that you got 4, and this is like saying 4 to the first, and so use the power properties. That's 1 times 3, that gives you 3. And then x, which was squared, but so 2 times 3 is 6, divided by, this will be 5 to the third power, because this gets attached with that cubed as well, and y to the third power. And I don't know what 4 times 4 times 4, that equals what, 64? X to the 6 divided by 5 times 5. This gives me 125. And 64 divided by 125 in lowest terms is essentially that. So this would be our final answer. Again, looking at B, we have this fourth power goes to each of the values, so it goes 4 to the fourth. We got c to the fourth divided by d to the eighth. And so what, 4 to the fourth power ends up being what, 256? C to the fourth divided by, okay. And let's see here, I'm gonna get some more room here. Okay. All right, this first parentheses where it has 3 divided by 8m to the fifth, there's no exponent attached there, so I'm just gonna rewrite it as 3 8m to the fifth multiplied by, now we're going to use the power properties first, so I have m, and I got that to the fourth, but I have to take it to the third power too, so 4 times 3 is 12, divided by n to the second, but that also gets attached to the third, so n 2 times 3 is 6. So now if I multiply this across, I have 3m to the 12th divided by 8m to the 5th n to the 6th. Now I can simplify this more because I have the same bases of m and m in the numerator and in the denominator. And so I can use the quotient product property to say that this is 3, and we got m in the top, and 12 minus 5 gives us 7, divided by 8 n to the 6th. And that is how we solve exponents using quotients. Hope this helps. Until next time.